Hello everyone, and welcome to today's workshop on coastal interactions for the Copernicus WEkEO service. So my name is Gail Enav-Sterbik, and I'm a training officer at Mercator Ocean International, and I'll be your host for today. So as you know, we will have a 2 days workshop, and today we will have a more introductory session where we'll tell you about what the WEkEO service is about, what sort of data and products you can find, and also what sort of applications you can do with the data we provide to you. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, you need to access the audio logo on your bottom left part of your screen if you want to be able to hear us. And then we ask you not to use the chat that you see on your right side and for your questions. So you can use it for small talk or to say hello to us or to each other. But if you have a more technical question or if you have any other question, you need to use the Q&A section. So it's a little slow. So the Q&A section, you can find it on the website. So it's on the top bar of your page. You will find the Q&A button. And then if you click, you will see an area dedicated to the Q&A. And that's where you can ask our speakers your question for today. You will also find a survey about the workshop that you can answer at any time. You can change your answer after also if you want to modify something. Okay. And so speaking of the presentation and the speakers we will have today, so we will have many interesting presentations. First, we will start with an introduction to the WEkEO service. And then we will have a presentation of the Copernicus Coastal Hub by Muriel Lux from Mercator Ocean International. After that, Anna-Lena Edman from EUMETSAT will give us a presentation of a WEkEO tool called EOCanvas for cloud-based data processing. And then, after a short break, we will have 3 presentations about specific application of these WEkEO products. So first, we will have Bojana Horvat from the University of Rijeka. Then we will have Jérôme Benveniste, so a former advisor at the European Space Agency and now chair of COSPAR, so Committee on Space Research. And finally, we will have Paolo Ciavola from the University of Ferrara. So it promises to be a very interesting morning, and I hope you enjoy it. So I will go first for the WEkEO introduction. So what is the Copernicus WEkEO service? So WEkEO is a DAS or Data and Information Access Service. It was basically created to facilitate the access to Copernicus and the Sentinel environmental data in WEkEO, and it is a program funded by the European Union. So WEkEO is operated by the different entities that are entitled to manage the different Copernicus services. So as I said, if you haven't heard of Copernicus, it's a European Union program dedicated to Earth observation and to monitor the Earth. We have different entities that are responsible for the different services. So we have Mercator Ocean, we have ECMWF, EUMETSAT, and the European Environment Agency. The WEkEO portfolio and the services are the following. So we have the Copernicus Land, Climate Change, Emergency Monitoring Services, Atmosphere Monitoring, and the Copernicus Marine Services. So beside that, and the services, we also have Sentinel missions, which are the satellites that provide the data that you can find in Copernicus. And they also have some missions, which data you can also find in WEkEO. So, and all of the data are free of charge to access and to download. So you just need to have an account on WEkEO. So if we dive a little bit more into the details of each service, so the Copernicus Marine service data is divided in 3 oceans. So we have the blue ocean, which is the physical state of the ocean. There is also the green ocean that describes the biochemical processes in the ocean. And the last one is the white ocean, so the life cycle of any kind of ice floating to the surface of the ocean. For the Copernicus Land Monitoring Service, so it provides geographical information on land cover and its changes, so land use, ground motion, water cycle, vegetation state, and Earth surface energy variables. And they cover the global scale at mid and low spatial resolution. There is also at European scale, which has a higher resolution, and they also focus on different hotspots, and they use imagery and reference data. Concerning the Copernicus climate change monitoring services, so they support society by providing information about the past, present, and future climate in Europe and the rest of the world. So their main goal is to support adaptation and mitigation policy of the European Union. So the Copernicus Atmosphere Monitoring Service on this side, so the data sets contribute to a comprehensive understanding of atmospheric composition, emissions, radiative forcings, and solar radiation, enabling informed decision-making and research in various fields. And finally, the last one, so the Copernicus Emergency Management Service, so they support all actors involved in the management of natural and man-made disaster by providing geospatial information to inform decision-making. So this service is constantly monitoring Europe to forecast, analyze, and provide information for resilience strategy. And what is currently offered on WEkEO is the early warning monitoring, so which offers anticipatory geospatial information at European and global level through the following system. So the first one being for floods, so the European and Global Food Awareness System, which we will have a presentation later on the day. And the second one is the European Forest Fire Information System. So now that you know a little bit more about the different services, how can you access WEkEO? So through its website, you will be able to find a catalog with products, and you will find more information on computing resources, you can find use cases, and you can access the event that we organize and many other materials. Also, the three main points of WEkEO and why it is an advantage is that it provides direct access to the Copernicus services data, which is directly linked to the original sources, so the data are not a copy. So this access is also harmonized. That means that facilitates some programming or an analysis that you might need to do with the data. And besides that, there is also an active user support, which you can always contact and ask any question you have related to the data or how to access the data. Okay, so as any Copernicus delivered data, the data to WEkEO, so the access is free and you can download the data. It's also free of charge. It's an open source environmental data we provide, so everything is free of charge to download and access. You also have free access to e-learning materials, which we have, for example, Jupyter notebooks, and then we have a section, if you're, for example, more experienced and you would like some computing power, it's the part where we apply a cost to it, but for the rest, so visualize, download, and everything, it remains free and it is open to everyone, as I said, as long as you have a WEkEO account. You can also have an access to a Jupyter lab, sorry. So if you have heard of Jupyter notebooks, this is a nice way for you to learn how to use the data, how to do basic analysis and kind of track your evolution, because we share it through our Jupyter environment and you can learn a lot through this platform. And for that, you can also access our Jupyter notebook gallery. So this is where you will find a lot of notebooks already developed on different services. And finally, as I said, if you have any question, it is very easy to contact the user support. So you can either do it by email or through the help center on the website of WEkEO. And it's very easy to ask them any questions. There is also a lot of already published articles on the frequently asked question. So that's all for me for today for the introduction. I hope you got a little glimpse of what the service is about. And now we will dive a little bit more into the project itself. So I'm inviting my first speaker, so Muriel, to take the floor and do the Coastal Hub presentation. Welcome, Muriel.
Good morning, everybody. So I'm going to share my screen so that... Okay. Okay. Is it okay?
Yeah,
do you see my screen well?
Yeah.
Okay. So I'm Muriel Lutz from Mercator Ocean International. I'm responsible of environmental policy and major account management. So I'm here to present you the Copernicus Coastal Hub and to explain what it is. Actually, it's a kind of subset of the WEkEO portfolio. I'm just going to explain this. So as Gael just mentioned, there is 6 Copernicus services with very huge amount of data each, and there is 4 Copernicus thematic hubs. The thematic hubs are actually that are currently online are the Health Hub dedicated to human health, mental health and well-being. There is also the Coastal Hub, the one I'm going to talk about, dedicated to the management of human activities together with coastal ecosystem protection. The Energy Hub, connecting Copernicus data to the green energy transition. And the Arctic Hub in support to the EU Arctic policy. So what are the main objectives of these thematic hubs? As I mentioned, each Copernicus services provide a huge amount of data. And the idea of these thematic hubs was to facilitate the access to thematic data, to facilitate the use for the users. And the main objective are also to help implement EU policies, to facilitate the use of Copernicus at national to local scale, to cross-fertilize between Copernicus services and not to work in silos, and to facilitate the thematic collection of needs and gaps from the users. These Copernicus thematic hubs were officially launched at the EU Space Week in November 2023, 1 year ago in Sevilla. So why a coastal hub? As you must know, the coastal environment is characterized by a complex land-sea interaction, and there is a need for the coastal manager, the decision maker, to access fit-for-purpose information, to support evidence-based decision-making, to promote sustainable management practices in coastal zone, and to collect the needs. So how to reach this coastal hub? So this coastal hub is indeed a new entry point to access all the Copernicus data available. This corresponds to a selection of the WEkEO portfolio, providing access to coastal data only from all the Copernicus services and sentinels. And there is also a dedicated user support. As Gael already showed you, you access the catalog, and I will make a short demo just after, and you will access all the different Copernicus services, all the datasets that are available. The entry point is coastal.hub.copernicus.eu, and there you will find many use cases and a visualization tool to explore the datasets. As Gael mentioned also, we have a dedicated user support, which is organized as follows. We have a 2-level user support. The first level to answer the basic question, And the second level is for more scientific or thematic question. And we ask directly to the different interested entity of the Copernicus service to answer the question. So, in a nutshell, what the Copernicus Coastal Hub provide is different fit-for-purpose data regarding the geosphere, the atmosphere, the biosphere, hydrosphere, and cryosphere, all gathered in the single portal. All these data are open and free, and they're concerned at the moment only European coastal zone. As I mentioned just earlier, the Copernicus Coastal Hub also provides many examples of thematic use cases for decision making. The use cases page is organized as follows, with different thematic regarding water. It includes water quality, water reservoir, flooding use cases. Another thematic concern the pollution, the land use, river discharge, air quality, water quality, and the spatial planning for the third topic, and which provide information and use cases regarding coastal erosion, marine protected area, aquaculture, renewable energy assessment, and so on. And this is the visualization tool in which you can access all the products. Now I'm going to make a short demo if it works well. Okay, so here is the landing page of the Copernicus Coastal Hub. So you have several tabs here providing information regarding this hub. In news and event, you will have what are the call for tender to encourage the development of use cases. Some information about the event where the Coastal Hub is presented. In data and viewer, you will access this visualization tool in which you can download, select a Copernicus service or an area or a variable, and then select a product and include it into the viewer. So you have here access to different kind of data sets. I won't enter into detail, but if you need more information, you can ask to our user support. Do not hesitate. They are very efficient. And then regarding the visualization, you can also change the color bar, the minimum and maximum of the visualization you select, and it can be very useful. Okay. This is for, oh yes, and what is very important is that from this viewer, you can download directly the data and give the subset, the geographical area you need, the variable you need, and the period you need, and then you can request for the data directly. If we come back to the page, or if we go to the use case page, you can reach here. So as I just showed before, you have these different themes regarding the use case already developed. So here, for example, if we select pollution, we reach many information regarding different use case, meaning that they are quite a demonstration of what we can do with the Copernicus data. So I invite you to have a look. And if you come back to the main page, you can also submit your own use case if you are using Copernicus data for any application from the Coastal Hub. You can submit us a use case that can appear one day in this page. And we have here the user corner and the chatbot to ask your question. So that's it for me. I don't know if you have any question I can answer. Thank you.
Thanks a lot, Muriel, for your nice presentation. So right now we have only one question for you. So if you can go Q&A. So, obviously, is there a plan for global data for the Copernicus Coastal Hub?
Yes, for sure. The objective would be to enlarge the coastal hub to at the global scale. Actually, for example, in Copernicus Marine Service, the one Mercator Ocean is implementing, the global data have less high resolution than the regional model we have for the European waters, but we have global data. We can use this data for the coastal application, but the idea of the coastal hub is to have the higher resolution possible in the coastal zone. But we will expand the coastal hub to global data as well, for sure.
Okay, that's great news. Thanks. So we have this question: are the use cases uploaded for free?
Yes, it is free. We have a review process to look at the proposed use case. Then when you submit, we have an analysis of the use case. We can have some question to finalize the way it is written, but there is no charge for this. It's completely free.
Okay, thanks a lot. This is question still about the use case. How can we submit use cases for the Coastal Hub? I guess they have to send an email to someone.
In the page, when I made the demo, in the page you have this button, add a use case. If you click on it, you access a form to be filled in, and then you click on submit, and it's automatic.
Okay.
It's an online submission.
Okay, great. Thanks. Next question. So lots of questions coming. Any provision to upload ROI or shapefile and accordingly download the data from the Coastal Hub?
Okay. Actually, the visualization tool we have in the WEkEO portal as well as in the Copernicus Coastal Hub is similar to the one we have in the Copernicus Marine Service. In Copernicus Marine Service, we can upload a shapefile, for example, and made a subset of the data according to this shapefile. But for the moment, the visualization tool in WEkEO and the hubs is not able to do it. But this is an evolution we have in mind. But I note this.
So we have a question. We have several questions actually about so in which format can the data be downloaded? So
I think there is only the NetCDF format, but I must check. But I think that all the data we have, for example, in Copernicus Marine are in NetCDF, and you can only download them in NetCDF format. There is a new functionality allowing, but it's just very new, but it's not completely finalized, to click on the map and to have an idea of the time series at a point. And I think that very soon, in the following weeks, we will be able to download this time series in a CSV format and so on. But for the moment, it's not possible to download it, only to visualize it. But I think that all the data are accessible in NetCDF format.
okay.
For the moment.
Okay. So new update coming soon. So can we download data for research or academic purposes? So yes, of course, it's the main point
Yes.
here.
It's for any users, I would say, because we want to facilitate the use to any kind of user. It can be scientific, it can be academic, it can be a decision-making use. Yeah.
question still on the data. Can I use this data to access water stress? I would say yes, you have to calculate it yourself. I don't think we have a product with this already calculated, if I'm not mistaken.
There is many products regarding the water bodies in the land service and the water levels. So I guess this is you can use this data to assess the water reservoir, if it's the question.
Okay. So lots of questions coming in. So a few questions. So this one saying, is data available related to European region only? So as we said on the Coastal Hub, for now it's only on the Europe, but all of the services are data all around the globe, especially like at the Copernicus Marine Service, depending on what you want to study. Which is also a little bit like this question, if this online system can be used in Liberia. So I would say yes. Yeah.
Yes, sure. But actually, since the Coastal Hub is a subset of WEkEO, if you need data from Liberia, you just have to go to the WEkEO platform and you will have all the global product and the regional product. So it could be the easiest way.
Okay, so we have plenty of questions coming. I don't know if we will have time to do them all. So are data from different regions, do the data from different regions have the same collection methodology?
Yes, actually, all the Copernicus service have been organized to provide harmonized data with the validation process, a quality check process. So it's not just a place where any provider can put the data. There is a very active and long process of quality check and specified requirement active.
Okay, thanks a lot. This question asking if we have any data for the plastic pollution.
As far as I know, there is no plastic source data, for example. But all the information that are interesting for the plastic pollution, the diagnostics are the current. We provide in Copernicus Marine Service the currents that are the main factor of distribution of the plastic. But we do not have any data regarding the data source itself.
Okay, thanks a lot. Another question about the use case submission. Once the use case is submitted to the hub, is there any peer review to assess the quality of it?
Yes, sure. As I just mentioned before, we have a peer review, and we come back to the person to ask questions to learn more about it, because the use case is very simply described on our page, but we have to know more about what has been done before publishing any document.
Yeah, obviously. Okay, thanks. Still lots of questions coming. So what is the difference between these three platforms, Copernicus Marine Service, the Coastal Hub, and WEkEO?
Okay,
Good
very
question.
easy. Very easy one. The product you will have, you can reach are the same. The idea, the European Commission defined this different portal to facilitate the user journey. Copernicus Marine Service is providing the information about the oceans, the marine waters. WEkEO is providing access to all information from all Copernicus service, so that the user can access land information, marine information, atmosphere information at the same place. The idea was to facilitate the user. It's not mandatory to reach many portals to have the data, but you can download them from a unique portal, but the data are the same. And the Coastal Hub is like WEkEO. It's the same philosophy, but with a reduced portfolio. Only the most relevant data, the most fit for purpose data from WEkEO regarding the coastal. So it's WEkEO, for example, maybe you have 400 products, and in the Coastal Hub, there is only, I don't remember exactly, 50 products. It's much more easy to navigate into the portfolio because you have only the coastal data available here.
Thanks a lot for the explanation. Okay. One question about how to download the data. Are the API the same between Copernicus Marine Toolbox and the WEkEO HDA? I don't know if you know.
I would say yes, because I don't think that we can reach our marine data store in different manner. But I would say yes. Maybe this is something to check with the technique, the IT team. But for me, there is not several way of accessing our marine data store.
Yeah, I think you can choose the Copernicus Marine Toolbox on WEkEO, but you have the same means to download the data except for this toolbox. So normally it should work the same.
Yeah, maybe.
Okay. So we have also some question about data that can be visualized. So why the glow FAS river discharge is not viewable? Isn't there?
It seems to me that is not viewable effectively, but it's downloadable. Actually, in WEkEO, and it's the same in the hubs, to be viewable, it means that the provider must create a web service, a web mapping service access to the data. And when the data are not visualizable, is because we do not have this WMS link to the data. But if you download the data, it's a netcdf file, you can use a classic tool to visualize the data. I did it with the GLOFASS data already. So, but it's true that for the moment, but this is an ongoing task. We try to ask the different WEkEO provider to make the data visualizable, but it's not a 1 second task. So
okay, thanks a lot to keep in mind then. So I have two questions about so the resolution. So this one is, does all layers have the same grid resolution? I have the same with the temporal scale of the data. If I'm not mistaken, everything is detailed in each product and it's not the same resolution for everyone.
Yeah, effectively, each product has its own characteristics. We have already had this need from the users that even for the non-scientific user especially, even if, or maybe the scientists as well, even if the products are not in the same resolution, temporal and spatial, some users would like that they ask them to be interpolated in the same grid to be to download all the products on the same grid. But for the moment, it's not possible. But this is something we have in mind, that when you download several products with different grids, there is a task process after that to put them on the same grid to compare or to compute indicators and so on. But for the moment, no, they are not in the same grid resolution.
Okay, thanks a lot. Okay, so we have a few questions like this one. So I tried to download data in WEkEO Viewer to do an analysis in my region, but I failed. Could you please assist me in identifying what I might be doing wrong? So for the second day of this workshop, so Friday morning, we will have a demonstration on the WEkEO Viewer. So explicitly for the WEkEO Viewer, I invite you to come back to watch the full demonstration. It will be like 20 minutes, and then you will be able to ask your question to the user support team, and they will be able to assist you with that kind of issue. So come back on Friday and we will show you the WEkEO Viewer. So still lots of questions. So we won't be able to do all of the questions, unfortunately, but so this one is, can we monitor coastal erosion using the Copernicus platform? So of course you can. You have land data, you have ocean data, you can definitely study the coastal erosion while using the Copernicus data. So don't hesitate to try and do that with the Copernicus data. So I had this question that was nice also. Can we use this data for hazard maps?
Do you want me to answer? Or?
I would have said yes, but maybe you can provide a more detailed option.
Yes, I think that within the list of the different variables and parameters we deliver, it can be sea level, it can be waves, it can be winds. I think that you have all the necessary information, and we have long time series. So it means that you can compute statistics and return period and so on. So I would say that you have enough material to build your hazard maps.
Excellent. So we have plenty of questions, but no more time for the questions. So I will put all of the questions that's left on the side, and we will answer to them in a post-event report. So no worries if your question haven't been read. And you will also have the replays and the presentation available after the event. So no worries for that. Well, thanks again, Muriel, for your presentation and the Q&A session. It was really nice to see the Coastal Hub presented. And yeah, so Annalena, whenever you want, the floor is yours for the EOCanvas tools. Welcome.
Thank you very much. Hi, everyone. It's great to be here and to see such a curious audience. I will share my screen and a few slides about a bit more of a technical topic on a new tool to be more precise. Okay, now you should be able to see my screen. Gael, can you confirm that everything works? Okay,
thanks.
Super. Thank you. So I have the pleasure to introduce you today to the WEkEO EOCanvas, which is a newly released tool. So it's like a month old or so really new. And its purpose is to process Copernicus data on the cloud. So in short, what is the EOCanvas? It's a very new WEkEO service for users, for everyone. It's a free service, so you only need a WEkEO account to try it out. It's a tool to process WEkEO and more data on the cloud. That means all the computational resources you need for process Earth observation data will not be done on your local machine, but will be done on our machines, on the WEkEO infrastructure. And it is a Python package. So this is not linked to, for example, the viewer or anything, but you can use it in your scripts, which you might have already set up for Earth observation processing. That is now all still a bit vague. So let's get a bit more into detail. Why should you use the EOCanvas for EO data processing? So this little image I prepared shows the kind of the common workflow when you want to process some satellite data or Earth observation data. So a user gets the data, for example, through WEkEO, through the WEkEO API. This then connects to all the Copernicus services, to all the Sentinel satellite data. Then you say which area of interest you're interested in, what time you're interested in, what products you're interested in, and what you get back is data. Then you download all the data and you have all the data on your machine. And then on your machine, can be a laptop, can be a computer, can be a server at your university, etc. You then have all the tools, you have the software you want to use, you have like the necessary processing resources, the storage space, etc. That's all on you. Now that works pretty well with 1 or 2 satellite scenes, but it can get a bit messy when you want to process large volumes of data. So what you get back might be terabytes of data. It is a high computational demand for your PC, and you have to manage multiple software installations. So if you have faced like those 3 problems in past Earth observation projects, then listen up now, then the EOCanvas might be useful for you and might be worth for you to try out. Because it tries to solve these 3 issues by process the WEkEO data without downloading, implementing commonly used software on the cloud, so you don't have to worry about software management, and process the data with the software on the cloud. So to come back to this usual Earth observation data processing workflow, using the EOCanvas, you might have realized, okay, the cloud is a bit bigger now. So the cloud is the WEkEO infrastructure. So what happens with the EOCanvas is that you make a data and workflow request to WEkEO, to us. In the background, still the WEkEO API connects to the data source, connects to the data and gets the data. But now the difference is the data is not downloaded to your local machine, but it stays on our infrastructure and is processed there using the commonly used geospatial software, GDAL, Data Tailor, Snap, etc. That always depends on the community, on the data, which is the most commonly tooled. And then the processing is done. And what you get back as a user is the result. So a really small, like a reasonably sized amount of data. I hope that was clear enough what the benefit is. And now I would directly jump into a demonstration, like actually 2 demonstrations. First, demo on like how to use the EOCanvas, like a small introduction, where we're gonna make a small subset of a huge satellite image tile. So we were gonna cut out this small thing, so in the end that you don't have to download this huge thing, but can only download that small thing. And the second demo is about how to make out of satellite data, which comes not on a regular grid, how to bring that to a regular grid on the fly using the EOCanvas. So let me change my screens and directly jump into the first demo. It's a Jupyter notebook on the WEkEO Jupyter Hub. So you can access that Jupyter Hub. Maybe I can quickly show this here. When you're logged in here with this icon, you can go to the Jupyter Hub. And within the Jupyter Hub, you'll find many training materials here in the public folder. And there you will also find the notebooks I'm showing here. So let's dive straight in. So the EOCanvas, it is a Python package, so you will need to have a Python environment. You will need to install that package into your environment, and then you will need to set up your credentials. These are your usual WEkEO credentials. And then it's already time to set up the processing workflow. So there are 3 necessary inputs for the EOCanvas to work as you want it to work. So the first is, of course, the data. So which data you want to process. Then the workflow. So which processes do you want to perform on the data? Do you want to make a small subset? Do you maybe want to select only one band? Do you maybe want to subtract bands from each other? And then the third thing is some configuration parameters. So what we're going to do here is we have a huge Sentinel-3 tile that is around like 600 megabytes big, but we're only interested in performing a process on this really small tile here. That is just a tiny subset of the data. But at the moment, if you would directly go to WEkEO and download the data, you would have to download the huge tile. And with the EOCanvas, we now see how we can just cut out that small tile here so that we do not, that your computer is a bit eased of the storage demand. The EOCanvas, it works with the WEkEO harmonized data access. So that is, well, just the API, which you can use to get the data. You will have to make a request. This is how the request looks like. In the viewer, there are many like supporting functions to get to this request. So you can use the graphical interface to get the request. And then you get an URL, and that URL is practically a pointer to the location where the data is on the WEkEO infrastructure. So you do not download anything yet, you just get this URL. And then this example now works with the software Snap, which is a commonly used software for the Sentinel data, but we also have other software implemented as on the serverless functions. For example, if you work with EUMETSAT data, the EUMETSAT data tailor, and it's a flexible framework. So if there is a user request to have some other software implemented, like something maybe you really regularly use, you can just raise that request with us, maybe through the user support, and then we'll see what we can do to implement also your software as a serverless function or like on the cloud. Here with Snap, we are inputting a processing workflow using Snap that looks like a nice workflow chart, flow chart. We read it, we subset the data, and we write the data. That is translated to an XML file, which is now the input to the function. And then the configuration parameters, it's just saying, okay, we have to unzip the data, but that's all happening in the background, so you don't have to worry about that at all. And then we put together the process already with our 3 inputs, the data, the processing workflow, and the configuration parameters. And then we send it to the server. And now this is all happening in the background. I ran this already this morning, so we don't have to wait now. It takes approximately 3 minutes to run this process. So to make from the huge 600-700 megabyte file a small file. And then you see the result has been downloaded, and it now lies in our working directory. Okay, this is now, we can now open the data set and we'll see how it looks like. Unfortunately, I see my script broke, but that doesn't matter. We'll see another example in the next notebook. So this is a first introduction on how the EOCanvas works. And now, as a second example, is what you can make out of it. So the second use case I want to show you is, okay, how to make this process of bringing satellite data to an identical grid and make a data cube out of it. So that's a second workflow. Again, we have like a smaller area of interest where we want to perform a process on. This time we have 3 different Sentinel scenes. We again set our workflow, we set our data input and some configuration, and then we submit all the jobs at the same time here. So three jobs are sent to the WEkEO infrastructure, and then it's doing its processing in the background. And it takes a bit longer. These are more jobs, but it takes around 6.5 minutes to get all the data ready. So 3 scenes. And then finally, we can visualize all the data in the Xcube viewer, which you can see here. So that's a component for visualizing Earth observation data. And we can now see the time series. So here is a time step. This is another time step of the chlorophyll concentration in the Baltic Sea. And that's it for the demo. I hope it was more or less clear. It's a bit of a more advanced package, but I think it's really good use, especially when you work a lot with the satellite data or the level 2 data, and you work with a high volume of data. The last minutes I want to quickly use on giving you the next steps for you if you want to use the EOCanvas. So what can you do now? You can, of course, try it out. Just go to the WEkEO Jupyter Hub, search for the notebooks, and then give it a try. I have added here all the resources, the example notebooks, the Python package documentation, and also the GitHub repository. It's a very new service, so there might be a little hiccup here and there. If you have any feedback or any questions, don't hesitate to contact us, contact the WEkEO user support. They will then answer your question or forward the questions to the developers of the package or to me. And yeah, then I invite you to give it a go. If you have like any specific use case in mind that require more resources, more quota, any other software than the software we have available at the moment, it's a really flexible framework. And of course, we do our best to support your Earth observation project. So you can contact, if you have like something specific in mind, you can contact again the WEkEO user support or also me directly. At that email address, and larger projects using the EOCanvas can also be realized as part of the Copernicus Innovation Lab, which is kind of a framework offering you the computational resources for projects that go beyond, okay, prototyping or demonstrator projects. So check out that link. Maybe that is the right thing for you. And it was, yeah, a pleasure to show you the EOCanvas, and now open to answer all your questions. Thank you.
Thanks a lot, Annalena, for your presentation. So we have a few questions for you, of course. So we are going to jump in for the Q&A for the EOCanvas. So a bit of a delay. Okay, so the first question is, so the files we downloaded from the cloud are in the format of Open DataCube. There is several questions on DataCube, so we are going to do.
So the format of the files of the download, you can choose yourself. I have chosen to download NetCDF files, but as we work with Earth observation data, they usually have the right dimensions, like the time dimension, latitude and longitude dimension, to then directly convert them, for example, to an X-array. So it's compatible with tools such as the Xcube viewer. And there's also the option, as for example, in Snap, to export or to download data as in ZAR format.
Okay, thanks. Okay, so this question still on DataCube. Can you download the process data, e.g. the DataCube you showed, and if yes, in what format? Kind of what you said.
Yeah, so the download that happens when you make a workflow or make a request. So you make a request on a satellite scene, and then that small part is then downloaded. So the file in a DataCube compatible format is downloaded. So if you now would go to this notebook and try it out, and you follow the exact same steps as I did, you will also be able to launch the process and then download the files in NetCDF in this example.
Okay. Thanks a lot. So yeah, we are going to put the link you showed for the Jupyter notebook in the InWay chat for the people. So if it should arrive in any minute, so no worries. So the last question we had on about the DataCube was this one. Can you explain what a DataCube is, please?
Yeah, DataCube, kind of a general concept of how data can be delivered. It's you know, in Earth system sciences, we usually work with data on different grids and with like many dimensions. So n-dimensional data, because we have the time, we have the latitude, we have the longitude, and then we have the different variables. And data cube is a format or a concept which kind of tries to harmonize that. So if you have data which is all on a regular grid, on a regular latitude, a regular longitude, regular time steps, then you talk about a data cube that usually comes in formats such as ZAR or NetCDF, and can then be easily analyzed, easily visualized, etc.
Okay, thanks a lot. So very useful. So this question, next question, is Acolyte integrated? So
Acolyte, no, it's not
Acolyte.
integrated. I haven't heard about this software, but it's I will check it out. And then yeah, we will collect all the software requests, and then we'll make an assessment on which software is like most relevant for as many users. So if you, I will write down Acolyte now and check it out. And if there are other people listening in right now who say, oh yes, we definitely need Acolyte, then just write a request to the user support or to me with that, and we will collect it, and then we will make the next evolution based on the feedback we get from you.
Okay, thanks a lot. I will also put the question on the side to remember this one. Okay, so this question, next question, can we automate processes in EOCanvas to run the script daily, for example?
So automation is currently not supported as part of the EOCanvas, but you can, I mean, it's a Python package, so you could integrate a scheduler in Python directly to execute the scripts.
Okay. Okay, thanks a lot. Good to know also. One question asking if EOCanvas is similar to the Google Earth engine.
It's a bit more specialized. So if you've worked with Google Earth Engine, you can like really easily accept huge volumes of data there. You will have to be a bit more patient with EOCanvas because we still get the data from the original source. You've seen in the example, it took a couple of minutes to process one scene. However, we kind of reward your patience with the ability to really make your own workflow. So everything you could do in Snap, every atmospheric correction, any band maths, any process, like really specialized processes or specialized process you do with any other software, can be implemented in your canvas. And there, I think it's the real strength. So to offer a cloud solution for also things which are not, for example, supported by Google Earth Engine, or data sets which are not supported by Google Earth Engine.
Okay, thanks a lot for your nice response. So the next question, so about where we can find the Jupyter notebook. So the link to the Jupyter notebook has been put in the chat. So I invite you to check it, to find it. The message will be in blue, so you should find it easy. So next question, does this mainly differ from Sentinel Hub in that the data is stored in the cloud? Also, is this service free and can it be used for commercial purposes?
For Sentinel Hub, it's a similar approach. Sentinel Hub, as far as I know, stores a copy of the data somewhere on their cloud and cloud optimized formats. So Sentinel Hub might be slightly faster on the data they support. It's specialized for Sentinel-2, I think. Whereas the EOCanvas, you can really access any data file, which is also available from WEkEO, and it goes directly to the source. So you will be always having access to the most up-to-date data. And the service is free, can be used for commercial purposes, but of course there are quotas in place. And yes, you can process your data within those quotas. Currently, the quota is 3 processes per hour, but that is also subject to change depending on what feedback we get. If you want to do a larger project, I really encourage you to check out the Copernicus Innovation Lab, which I linked in my slides, because there we also will support projects with larger quotas on the EOCanvas, for example, so that could potentially really speed up larger processes.
Okay, thanks a lot for the explanation. So I'm going to mark this as answered. Just before we go to this question, everyone will have the PDF presentation of every presentation we have today. You will also have the replay, and you will have all of the links and all you need. So don't worry about it. So next question. So I had a suggestion. Where can I access code IDs as to how I could tailor the data processing stage to suit my need?
So there are some example notebooks available. You can find them in the Jupyter catalog or in the Jupyter Hub in that section I linked. So you can get inspired there, I would say. And then I can really, if like I realize that it might be a bit hard to find that, okay, how can I start with the EOCanvas? So to really make that first step, I can recommend to just get a bit familiar with Snap, for example, because we have Snap implemented already, and see what you can do with Snap. And then like as a kind of reminder, everything you can do with Snap, you can also do with the EOCanvas. So if you have like a nice process you have in Snap and you want to move it to the EOCanvas, then it's usually just a small step. And if you face any problems, you can always contact the user support for help. But for the first step, if you really want to use it now, I would suggest to look into Snap and see what you can do in Snap, and then move to the EOCanvas.
Thanks a lot. Another technical question, is the CR2CC processors included in EOCanvas?
So I'm not a marine scientist, but I've heard about this processor. If I'm not mistaken, that is an additional plugin for Snap, and this plugin is included in the EOCanvas. So yes, it is.
Okay, thanks a lot. So we have time to 2 more questions, and then we will have to move on, but all of your unanswered questions will be put aside and answered in a post-event report, so don't worry. So this last question, is this, I find this tool powerful. Is it possible to have an accompaniment with you for a project of doctoral studies on the coastal zone in Guinea? I don't know if you do an accompaniment, I can say the word, but if you do tutorials or anything like that?
A tutorial specifically. So if you want to use the EOCanvas, I can recommend to maybe apply for the Copernicus Innovation Lab. And if you want to have a demonstration or a tutorial, we do training, so we would be open for that. Just drop me a message.
Okay, thanks a lot. Okay, so we will do the last question, and then we will so, lots of questions going. Is it possible to integrate this into a coastal zone monitoring platform?
Yes, I don't see a reason why not. So something I haven't mentioned because it goes into the technical details, but you can also connect, for example, object storage, so S3 buckets to the tool. So you're not so if you want to send the data somewhere to a bucket and then access or use the data like for a dashboard where you access this S3 bucket, that's possible as well. So we do have some flexibility here, and I don't see a reason why it should should not work with a coastal zone monitoring platform.
Okay, thanks a lot. So we will have to So thanks again for your presentation and the Q&A session. Thanks
It
also.
was a pleasure. Thank you.
Thanks.
Ciao.
Thanks also to Muriel for your presentation. We are now going to take a short 10-minute breaks, and so feel free to go grab a coffee or discuss with each other in the chat. We will see you in a few minutes for the use case. See you in 10. Welcome back, everyone. So I hope you had time to relax a little bit. Welcome back. We will now move on to the use cases presentation, and our first speaker is Bojana Horvat from the University of Rijeka. So welcome, Bojana, and whenever you want, the floor is yours.
Yeah, hello, thank you for the introduction. With this presentation, I will try to present the work we did within the project that was concerned with flood risk assessment. I was, in fact, responsible for preparing the spatial data for the flood risk assessment. Sorry, it's a little bit slow. Okay. Anyway, as you know, as required by the flood directive, each member state is obliged to create and design flood risk management plan, and essential part of those management plans are flood risk and flood hazard maps. Those maps result from the flood risk and flood hazard assessment. So in general, these are some general stages of flood risk assessment, which means first is derivation of probability and intensity of flood events and preparation of flood hazard maps, which is based basically on hydrological and hydraulic modeling. Then detecting the elements that are prone or exposed to flooding, and then relating those elements to monetary values and defining the flood damage that occurred during the flood. And in the end, of course, preparation of the flood risk maps. Each of these stages require a certain level of spatial and thematic detail in the data. However, not all the data is already available to be already applied at the various scales. Assessment of flood risk and flood exposure can be proceeded at 3 different levels. The first one is the largest one, which is macro level, and it involves pretty much coarse spatial data that covers the resolution of 100 to 1000 meters, then followed by the mesoscale, which is concerned with the smaller spatial units. Mesoscale can be applied to the catchment levels, and we were at this project concerned with this level. So it involves the spatial resolution of some 25 to 100 meters roughly. And the smallest and the most detailed level is micro level, which is actually the object level that covers the resolution of 1 to 25 meters. Although even on that level, a certain degree of aggregation needs to be applied, thematic generalization. We will not be looking at a separate object, but we will need to group similar object into one class that we finally observed when analyzing flood exposure. As I said, at this stage, we did analysis at the meso catchment level, which means that we required spatially and thematically data that is more detailed than the data that was already available, but collecting new data requires more expenses and it's quite time consuming. So we had to deal with thematically aggregated land cover and land use data and spatially aggregated census data that we collected from the statistical institution. Anyway, when preparing the data, the challenge was to reduce this generalization in data that is more suitable for the macro level. And to introduce a certain level of detail that will make this data applicable to our mesoscale flood risk analysis. We considered, when it comes to land use and land cover data, we considered 4 Copernicus land use land cover data sets, which is Corinne land cover, Natura 2000, coastal zones, and urban atlas. Most commonly, Corina land cover was used in such cases, although this data set covers practically the whole continent. when it comes to spatial and thematical resolution, it is not well suited for the mesoscale, meso-level analysis. So we had to consider other datasets, which is Natura 2000 and coastal zones. Of course, Urban Atlas is the most detailed when it comes to urban areas. However, it is available only for the certain regions. It's not available for the whole country, of course. So we had to apply certain regions, coastal zones, and Natura 2000. When it comes to thematical level, the most detailed in the urban regions is again Urban Atlas, followed by the coastal zones and Natura 2000, for example. It depends actually on the purpose of the actual data set. So if we were at this point, we were analyzing the data that refers only to the urban areas. So Natura 2000 is not thematically detailed enough. For example, it recognizes only one urban class, while coastal zones recognizes, I think, 3 urban classes. Urban Atlas, as opposed to those two data sets, recognizes 4. So we adopted that classification when it comes to exposure analysis of the assets in the urban areas. Along with land use and land cover data, we also used impervious density data that is available also from Copernicus in raster format. It's 10 meters resolution, spatial resolution. And along with IMD data, we also use the impervious built-up areas that are derived from IMD data. And these IBU data refers to the surfaces that signified the above ground buildings. So not all IMD surfaces are considered to be above ground buildings. So we needed to restrict the data only to the areas that are covered with residential or above ground buildings. When it comes to analyzing population that is exposed to flooding, we had to use census data. But also the census data has a certain degree of generalization since it is collected at the settlement level. By that I mean the administrative boundaries of the settlements, which is illustrated in this choropleth map of the census data, population density data for the settlements in our research area, which is the Zadar catchment. So we had to apply certain disaggregation not only to land use land cover data, but also to the census data, so we can proceed with exposure analysis at the meso level. Data disaggregation is nothing more than regionalization of the observed data using some auxiliary data. In our case, we used imperviousness density data as auxiliary and applied it to both census and land use land cover data. After finishing the exposure analysis, we did the flood damage analysis, which means connecting these exposure results that we got with some monetary values via depth damage curves that are already available for the whole continent, for the EU countries. Just to proceed with data disaggregation, we needed to make certain assumptions. Since we used IMD data and IBU data as auxiliary data, so we assumed that population density is directly related to the impervious density, which means the higher the IMD values, the higher the population density will be, and more population will be exposed to flooding. Then we assumed that population resides only in the built-up areas that we got from this IBU layer, derived from IMD layer. And that we also assumed that IMD indicate the density of the built-up areas, not only the population density areas. by intersecting those auxiliary data with urban fabric that we extracted from the available land use land cover data, we got IMD spatially restricted to those residential areas, and then we overlaid it with census data to get the surfaces within the settlements that are probably occupied by the population. That's roughly the methodology we applied. When it comes to disaggregating thematically the land use land cover urban fabrics, it was more or less easy because we applied the same thresholds that were applied to Urban Atlas, which means we classified IMD data into 5 classes based on those thresholds adopted from the Urban Atlas. In this table, I just put also the thresholds used in other land use land cover classes just to illustrate the discrepancies between level of detail in all those used land use land cover data sets. However, when it comes to population density, the process was a bit more complex because we had to restrict the census data that we collected from the statistical institution to only those IMD polygons that are considered to be populated by people. This is the illustration of how we disaggregated population density data. We applied asymmetric population mapping, which is often used in these cases. First, we needed to establish the initial number of inhabitants in the areas that we previously extracted as the areas that is probably populated. And to do so, we had to use IMD as the weighting coefficients to assume the density at a certain levels of IMD classes. Then we, with the procedure that is described here, we limited the initial number of inhabitants to those areas that were distinguished in the previous steps, and estimated population density first on the pixel level, and then aggregated it to the polygon level of the land use land cover data set that we adopted for the certain region. To validate results, we used the case of Zadar catchment because we had Urban Atlas data available for this catchment. So when we compared calculated, estimated, and actual number of inhabitants and population density, we actually got pretty good results. Just to conclude this short presentation, we established that this disaggregation technique that we based on functional relationship between the aggregated and auxiliary data, in this case IMD, is one way of dealing with lacking the data that has no sufficient thematical and spatial detail. We used already available Copernicus land cover, land use, and IMD data. So we used it as the auxiliary data to disaggregate not only the exposure of the assets, but also the exposure of people in the flood-prone areas. However, we have to emphasize that this approach is limited by the existence of the census data. If the census data is collected at the settlement level, this approach can be applied. However, it is not always the case. In this case, some other data sources needs to be used for the census data. For example, I put here illustration of the world pop data, which is available at 100 kilometers resolution. And also one drawback in this specific study was that we used census data that registered only the residents that are living at the actual settlements. We didn't take into consideration daily or seasonal migrations due to work or due to tourist season. So in some further steps, this also needs to be taken into consideration. Okay, so that would be it from me. I see that I'm practically in time. So if you have any questions or suggestions, I'm very open to it. Thank you.
Thanks a lot, Bojana, for your nice presentation. So at the moment, we don't have any question. We can wait a few seconds if some are coming. Okay, so yeah, we have question. So I will wait till it appears on the screen. Okay, so this question, so the data is used from a static source or processed real time. Thank you.
No, the data is used from the static source. It's not real-time data. We use the census data that was collected, I think, in 2021, and land use land cover that was derived from Copernicus Land Monitoring Service.
Thanks a lot. So this question, so this one is a general question. Where can we access the presentations that have been done so far? So all of the PDF presentation will be made available on the website just after the event. You will see an option with replays and presentation. So you will be able to access the presentation and take a look at the slides. This question, how to aggregate data from extreme flood events?
That's a difficult question to answer. Yeah, I have no experience with aggregating from these extreme flood events. Yeah, well, aggregation is actually, in my opinion, would be much easier than disaggregation of the data if you have some the spatial units to which you have to aggregate the data that you got from your studies. I think it's quite straightforward in GIS environment. Yeah.
Okay, thanks a lot. So we have this question saying the world pop is it not 100 meters or is it 10 kilometers spatial resolution? I'm not sure to understand the question.
Yeah, well, I'm could be that I wrote the wrong resolution. I'm not sure actually now. I think it's 100 meters. Yeah.
Okay.
Yeah.
Okay. Thanks for the precision. So we have this question: if the disaggregation method can be used for different studies, like the human pressure hunting on a species.
On a species. Well, I'm not sure if that would be possible. Actually, this method specifically is designed only for detecting the elements exposed to flooding, static elements exposed to flooding. So I don't know. Maybe if you find a way to apply this method, I would be very happy to hear about it. Yeah.
Yeah. Maybe there is work already done on this. We should look on the internet. Okay, so that's it for the question, I think. I don't have any more coming, so thanks again for your presentation, Bojana. We will put your slide on the website for people to take a look and send you an email if they want. So thanks again for your participation.
Thank you.
Okay, so now I will welcome Jérôme Benveniste for your presentations. Whenever you want, the floor is yours.
Thank you, Gael. So I will speak about the sea level rise and coastal hazards. Whoops. Okay, so next slide. So this material is coming from an ESA contract, which I launched and steered in the last 2 years, called Earth Observation Advanced Science Tools for Sea Level Extreme Events, EO at Sea. And basically, I would like to remind you that the coasts are crucial for humanity, with 40% of the global population living within 100 kilometers from the coast. And they face growing threats from climate change, like rising sea levels, coastal erosion, extreme weather. And managing these vulnerabilities demand a comprehensive monitoring to ensure sustainability, disaster risk reduction, and scientific knowledge of processes. And satellite plays an indispensable role in monitoring coastal dynamics, providing global high-resolution data on parameters such as sea level, wind, waves, and etc. And you remember what just happened in Valencia, and we have an example here in South Brazil, where there was a dramatic flooding event. It was the 4th climate disaster in 1 year in this area, the South Rio Grande do Sul. And so basically what happens is you get extreme precipitation, you get strong wind pushing the water to the coast, and also a storm surge, which rises further the sea level. And okay. I'm sorry, the buttons don't appear. Why did the buttons? Okay, then now they appear. Okay, so let me just try to find. Okay, so the objective of the project was to bring together Earth observation experts and coastal modelers to perform a reconstruction, a data-driven reconstruction of extreme sea level events, and enhance the scientific understanding and predictive capacity of ESLs, and better prepare for impacts and risks of the ESL events. And so we started with a requirement analysis. We needed to identify the needs. So we started with a literature review to define the main scientific challenges. Then we had an expert discussion to assess the potential methods and feasibility within this project, which is always limited in resources and time. And then we organized a scientific workshop requirement to co-design our project with users. We had a very strong participation to more than 200 people from 42 different countries, and everybody requested the recording so they could look at it afterwards. And so out of the 80 requirements, we prioritized, and we chose, because of limited resources, the 2 major ones. And we looked at the priorities and what people were asking for. Essentially, it dealt with accuracy and the capacity of the system, and the design characteristics. So we went on and we gathered an extreme experimental data set, and we located on 6 different use cases, like the Dutch coast, the Adriatic Sea, the Tagus estuary in Lisbon in Portugal, and the Azore Islands, and the northeast coast of Madagascar, and also the Marshall Islands in the Pacific. And so this data set, basically, this is a very important slide because it's the data that you might want to be looking for if you want to do on such an application. And so we looked at the short-term processes and also analyzed the long-term processes in order to give some insight of what could happen in the future. So bathymetry, topography, land use, land cover, we just heard about. Vertical land motion also is a very important contribution to sea level rise. The absolute sea level rise, the relative sea level, the tides, storm surge, waves, and so on. River discharge also, and flood mapping. For the long term, we looked at shoreline position and many other important things like the potential storm surge flood map. So the scientific approach, basically, so we had these 6 use cases, and we looked at the short term and the long term, so both requires modeling, and we constructed the TWL, so this is the important acronym that you should remember all throughout this presentation. So it's a total water level. We looked at specific events, and we looked at constructing a 20-year time series and analyzed what we got, and for the long term, we looked at historical trends. So the sign cases were based on predictability. We're focused on predictability, the process understanding, and the risk and vulnerability assessment. So the scientific challenges were the drivers of extreme sea level and the nonlinear interactions. It's a complex compound system, so there are interactions between the different drivers. Then the dynamic morphological response to the coast to extreme events like coastal erosion, and the extreme sea level and the tipping points for coastal impacts to look into the long term. So the scientific highlights coming out of this project. So we reconstructed the total water level. So it's basically the sum of the astronomical tide and the storm surge, the sea level anomaly, and the wave run-up. So, for instance, sea level anomaly here, we have satellite radar altimetry satellite tracks, which allow us to build this component. So we'll see the component one by one. So here you have, you start with the mean sea level, and then you take into account land subsidence. So basically the land goes down, and then things go up, like the relative sea level size. The tide goes up and down with different amplitude and variation amplitude across time. The seasonal sea level anomaly, basically the normal, they say the mesoscale anomaly, of course, but also seasonal oscillations like El Nino or the North Atlantic Oscillation. And then there's the wave. So the wave basically, well, there's a storm surge here, and due to, for instance, the atmospheric pressure lowering, so the water goes up if there's no pressure pushing it down. And then the wave setup and the swash, so the total of setup and swash is called the run-up. And so we'll see this in detail. So storm surge comes from the Mode 2D dynamic atmospheric correction, which is developed at Lagos in Toulouse. The atmospheric tide also comes from the FES model developed at Lagos in Toulouse. Then the wave run-up, we tried 2 different models. The wave earth model, which is essentially wave height and wave period, plus taking account of the beach slope. And we looked at the Stockton model as well, which provides also an estimate of the run-up. So the sea level anomaly, it comes from Extract, which is also coming from Lagos in Toulouse. And we used all the satellites that you can see here on this map, all the radar altimetry satellites available, and which allows us to have a very high temporal resolution. Like, for instance, if you take the Adriatic Sea here, you have a couple of days of revisit time. And we checked the binning, like 1 degree, 2 degrees, and so on. And we have a very significant number of samples to build this sea level anomaly. So the use case I told you about, basically, they're low-lying coastal environments with high exposure time. And this covers the enclosed sea, the open coast, and the oceanic islands. And so this is an animation of, here you see the run-up, and in purple, and you see the storm surge, the sea level anomaly. This is the tide in orange, and the total water level in blue here. You can see it with this visualization. You can zoom, you can do averages, and you can see, for instance, you can zoom, like, for instance, around November 2005 here, you have an idea of what the total water level looks like. Basically, this is the zero here, and so the tide makes everything oscillate, but then with the storm surge, you have peaks up to 2 meters. So then we wanted to do the flood risk assessment. So we used 6 different digital elevation model, and we tried and we produced different flooding scenarios. You can look at which one here on the slides. Then we saw that not all the dams are capable of capturing the connectivity and the way that the flood is going to happen at the coast. And so pick the right one. And then we look at the influence of shallow water. So we have this historical evolution of shallow water made by satellite-derived bathymetry. And this animation shows you the different types of waves that hit the coast here. And you see here there's overtopping. And we did that for different storm events, and basically where the water level was also around 2 meters. We looked at the satellite derived topo and bathymetry. We focused on one of the atolls of the Marshall Islands here, and you see in the movie here you use the Sentinel-2, then you derive the bathymetry, you compare with worldview, and you look at the bathymetry evolution, and basically all the scenarios that we produced with this bathymetry and topography, they were more or less in line within 30%. We could do better. So basically, the scientific outcome from this activity, we looked at satellite-derived bathymetry, which has a very important impact on how the flood is going to happen, especially for the wave run-up. We reconstructed the total water level at specific times in high resolution and in the long term to see the trends. We also looked at the shorelines, the evolution of the shorelines. And we compared the altimetry with the different models. And you can see in those 3 plots here that the model and the altimetry are doing pretty good. So the model is a good way to interpolate the bathymetry when the satellites there. So we produced reports for different technical reports. We presented in different places. We're producing now 9 scientific manuscripts, and I'll show you also that you can also publish your paper in a special issue. So the main challenges and the limitation coming from this work is that topographic and bathymetric data in high resolution are very important. It's crucial for modeling the coastal processes for extreme events. The increased spatial, especially temporal resolution is very important for monitoring the drivers and looking at the impact, like flooding, of course. And the EO-based measurements, like sea level, waves, and wind, they need to be retrieved a little bit closer to the coast. So like altimetry is difficult to do close to the coast due to the presence of the coast, which is polluting the measurement. And some variables from Earth observation are not available, and in situ data also is widely not available, not well shared. And like, for instance, wave run-up is difficult to gather. Just a word on model. Of course, it's a complex problem, so it requires a multidisciplinary approach. And for the short-term simulations, we could incorporate more nonlinear interactions, considering the complex and compound nature of extreme events. So we looked at societal impact, and the challenges are associated with scaling up, and particularly in terms of ensuring data consistency and model performance across different regions. The operational framework is necessary to provide this as a service. And the Coastal Vulnerability Index also is important. So we ended up with a roadmap. Basically, everything is going to be consigned in this special issue. Then we are promoting these results at different conferences, like one in Brazil, the Living Planet Symposium of ESA, the COSPAR Scientific Assembly of COSPAR, and publishing more digital content. But basically, we need to go towards an operational supply chain, and we certainly need to improve our skills, so foster more research to develop next generation of total water level products. And we need to work on improving individual components and eventually adding new enhancements and current limitations. So there's work to do. So which should lead to an operational concept, which is a pathway for adaptation within digital twins. And so it's a multi-source problem to cover multi-hazard and look at multi-impact like erosion and flooding. And it's a multi-scale. We need to provide early warning, but we need to understand the long-term risk. Hazard observation and forecast needs to be done with numerical modeling, which are data-driven. And also the morphology part requires also a forecast if you want to help people take decisions about protecting the coast at national scale, at local scale, and look at the short-term events and be aware of what's going to happen in the long term. So this is the special issue in which we're going to publish 9 papers from this contract. And you're also, if you work in this domain and want to publish here, I think it's a good place, the International Journal of Applied Earth Observation and Geoinformation. Deadline is 15 February 2025. And I would like to say that in WEkEO, you can find data sets. Not all of the data sets that I showed you that we have used are yet found in WEkEO, but they might be in the future, especially if there's some demand. Of course, altimetry for Sentinel-3, Sentinel-6, and oops, doesn't move. Okay, so okay. And so also wave height you can get from WEkEO. And you can make a beautiful map with the tools that was presented earlier. This is of the 2nd of December, the map in the Mediterranean Sea of wave heights. And I advise you to stay tuned to the ESA Extreme and Disaster Science Cluster. It was launched to promote networking, and it involves several ESA-funded projects. If you want to apply for a postdoc and work in this group, go to EO for Society at esa.int. And I'm done here, and thank you very much. Don't hesitate to contact the people that did the work under my my leadership, and myself if you want more about this. Thank you.
Thank you very much, Jérôme, for your nice presentation. It was a huge hit in the chat, so lots of people were happy with it. So we are going to move on to the few questions that we have. So, first question, how accurate is the satellite derived bathymetry?
So it's an interesting question. It really depends on the target, and it depends on the depth. So it works only with very little depth, and so the accuracy depends on the depth that you are looking at. So I would say from 1 meter to 5 meters, depending on the depth.
Okay, cool. Thanks a bit. So this one is not the question, it's to congratulate you on your presentation, which was really nice. Next question, what is the reason behind selecting the particular study areas?
Well, we had a long discussion, especially in the user requirement part, and during the workshop where we had 100 people logged in. Not as successful as this workshop, which is had 700 people, which is quite impressive. So congratulations to WEkEO. So basically, you understood that we want to check the different kinds of morphology. So enclosed seas, open island, and vulnerable coasts. And this is why we ended up with these different regions. A few in Europe, because we are quite interested in Europe, but also we wanted to look at the very low-lying islands in the Pacific, like so we took Marshall Island as an example, also because we had some in situ data. Because in situ data are very important in order to really work with Earth observation from space. And any place where there is access to in situ data is very comforting because you can do validation of what you're doing.
Okay. Thanks a lot for the explanation. So the next question, so interesting presentation, where the DAM 8 converted from the reference GeoE to MSL MDT.
So the DEM are reference to an absolute reference ellipsoid, like the GPS one, like the WGS84, and that gives us the absolute height. So then you're talking about the land DEM. So we use absolute heights. And then you wonder, where is the mean sea level? And so, yes, this is given as a mean sea level map. So it's a geoid plus the absolute topography.
Thanks a lot. So next question. Does the wind direction depend on TWL?
Well, I would probably revert the question. Does the TWL depend on the wind direction? Because we don't really control the wind direction. It just happens. And basically, when you get, like in the Brazilian example I showed at the beginning, you get the wind pushing the water towards the coast, and you get a higher sea level anomaly. And so the wind will create a modulation of the total water level.
Yeah, exactly. Thanks. And so this question about if the storm surge data was from WEkEO. So it was the part where you talked about.
This is a question I'm not sure I can answer myself because I don't know all the data set. They're so numerous, but I showed you that you get sea level anomaly from WEkEO. And you get also the waves, which is an input for the run-up models. And also, well, you want to know the storm surge part. It comes from this dynamic atmospheric model, which is at Lagos, called MOG2D. And you find this data in the altimetry data. It's one of the parameters in the NetCDF files with the altimetry.
Thanks a lot. So we have several questions. So I will read this one. What is the link to apply for ESA EO postdoc opportunity you mentioned? So we have several questions about that. The PDF presentation will be made available. You will be able to find the details about this offer. So do not worry, but maybe if you want to add some extra detail about that.
Well, basically, if you go to EO4, the number 4, society.esa.int, you see everything we do in R&D for Earth observation. And here you will have also announcements about opportunities for doing a postdoc in the Science Hub, where there's these clusters, ocean cluster, the hydrology cluster, and the extreme and disaster cluster. So EO number 4 society.esa.int.
Okay. Thanks a lot. Maybe we can also put the link in the chat for everyone to see. Thanks. So next question. What is satellite track if you make an AI for processing image? Will be that possible? Would it be that possible? And will will it make your work easier?
Yeah, so we use AI all over the Science Hub at EO for Society, Earth Observation for Society. The satellite track is just the fact that the radar altimeter is measuring right under at nadir, and so we have a track. You know, imagine just like you know when you roll a ball of wool, you have this this wool thread, and so this is the track. So it's a flight of the satellite, and so we get data under the satellite. And now we have launched a beautiful jewel of altimetry, which is a two-dimensional instrument called Surface Water Ocean Topography, so SWOT, and that makes a two-dimensional map. So it's not just a track; it's also a map. But that's really new. And so yes, we use AI. We use AI at different level of the processing, and yes, it will make our work easy. As long as we control what the AI is doing, of course, we have to be very careful with AI. And sometimes we don't understand what it does, but the output seems quite plausible.
Okay, thanks a lot for the explanation. This one question asking if it is applicable for both metropolitan and rural areas.
Yeah, so the different digital elevation model or digital terrain models allow us to see how the flood is going to take place and how the water is going to be circulating within the city, for instance, when flood appears in the city. And so this is what I call connectivity, where so yes, there are models which are developed to see step by step how the water is going to invade an urban area. And of course, rural areas are probably easier because the digital elevation model and the terrain model is much simpler because there's not much buildings and so on. So yes, we in the 6 DMs I showed, you could see the buildings, you could see the streets, and you could see how the water propagates during the flooding event.
Thanks a lot. So we have time for 2 more questions, if it's okay with you. So the almost last one is if you could quickly explain about the morphological evolution due to ESL events.
Well, this is essentially linked to coastal erosion, and we know that coastal erosion happens in steps. After a big storm, there's a drastic change of the coastline, and so this is the evolution. We follow the coastline year after year with satellite images, and also we look at the movement of the sandbanks with satellite derived bathymetry. And this is one of the slides. Also, you can go back to it and look at it, where we follow the evolution of sandbanks, which has an impact on the wave breaking and the wave run-up.
Thanks a lot. So now the last question for you for today, or more of an open question: how can local governments integrate sea level rise projections into urban planning and development?
Well, this is a very hot topic, and you know, for instance, in France, after the big storms that we had at the end of the last century, the President Sarkozy developed a plan, and for instance, it became illegal to build houses too close to the shoreline, and so on, especially in vulnerable areas like the islands that we have in the French facade. And the French facade itself. And so, yes, they do integrate sea level rise projection, risk analysis, vulnerability analysis, and the mayors and the prefects and the central government in Paris deliver construction permit or not, and most likely not. They produce a map where you have red, orange, and white, and where you can develop urban buildings or houses and so on. Yes. So it is taken into account, all the governments rely on this this kind of data to allow construction or not, and also to develop protections. Millions of euro are spent just on the French facade, but so many millions it comes to, I mean, maybe 5 million for 10 kilometers of protection. So you can imagine how much money is invested in order to protect the coast. And this is paid by the taxpayers of the whole country for the people who live near the coast. But same thing for landslides and things that happen in the mountains and like avalanches and so on. So yes, the government of many countries are very concerned by this. And
yeah, exactly. Well, thanks a lot for all of the Q&A. Thanks also for your presentation. And thanks again for joining us. So we will go to the last use case presentation of the day. So Paolo, whenever you want, the floor is yours.
Hello, Gael, thank you. I hope you can all hear and see me.
Yes.
Thank you, Jérôme, as well for your presentation, which opens the way to mine. I will talk about, just 1 second, okay. I will talk about work that was done officially for Copernicus through a project which runs, I think it ran in parallel with the one prepared and presented by Jérôme, which was financed in Horizon 2020. I will dedicate time only to a part of the project which I was in charge for, which was specifically about the coastal flooding database building. And I will show you the conceptual framework that was behind it, the challenge of doing this at the European scale. Keep in mind, bear with me, that we are at the European scale. So we have to ensure there is homogeneity of everything that is produced. I will deal specifically with a numerical model, a finite difference model, which is a standard used in Copernicus for EFAS, for the river component. Of course, we had to prove that the model was working at that scale, and this was part of an operational system, of a proposal to Copernicus to build a European system for coastal flooding. This was the name of the project. It was a proof of concept. We were not charged for putting up a European system, because that obviously is with the service providers. Was a rather small project which ran for 2 years, from January 2021, so has been finished for some time. You can see it was coordinated by Dr. Carmaroli at the University of the School of Advanced Studies in Pavia, and it involved a number of service providers like Mercator, CLS, and universities, as well as, in my case, it was a consortium where Ferrara is part of the university from. You can see the map of the partners. What was the challenge? The idea was to use Earth observation and non-Earth observation products produced by the Copernicus services. And as Jérôme said, when you do these kind of things, you have to go through a co-design and co-development exercise. In this case, was officially done through the Copernicus user-based community. And the idea is to go operational. So to produce an operational system, which given a provision of forecast of waves and tidal levels and sea levels, storm surge, produced by the Copernicus Marine Environment Service, we would then be able to produce not only flood maps, but also impact maps. Obviously, I will not talk about these. I will mention where you can find this information from. I will just focalize on the flood. We also produce an automatic shoreline mapping tool, which runs in a similar way to others. It's a new tool. I will not mention about this, but you can find it at the links. And the idea is to propose to the Commission a roadmap for integration into the Copernicus Emergency Management Service that you are all aware of. Why I said it's a challenge? Because it is a challenge to build the operational service at that scale. First of all, you have to identify appropriate modeling approach. You have to set up the model. I mentioned that you have to build the brick by brick flood layers at the European scale. And then you have to prove that all this work works reasonably fine. And then what you can do, you can use, instead of using a real operational system, given the scale, what EFAS, the river system, does, uses a flood catalog, which is what we did in the same way. You then are able to issue warning and produce flood layers, but also impact layers on population, infrastructures, and so on. He froze. I don't know if you can hear me, but here it was freezing.
We still can't hear you. I think it will go back in a few seconds.
Okay,
Perfect.
fine, thank you. We use this code, ListFloodFP, is an open access code, very much used for river flooding and coastal flooding these days. So what we did, first of all, we chose 17 test cases and tested 72 settings of the model. I will try not to go too technical, but you can find in the links I give you all the information if you want to go deep into it. Then we have to calibrate against observations. There are observations by satellite imagery, Copernicus Emergency Management Service activations, but we also built a historical database of floods using any sort of information, including local observations and citizen science observation too. You can find again in the project description of these, and soon this will be released at the European scale. And the forcing is provided by the Copernicus Marine Service, and all the other information on land use and so forth is provided by the coastal land use cover, which was mentioned by a speaker before. Then for a number of cases that you can see here, we did calibration and validation. We did a sensitivity analysis to choose which was the best and reasonable model setting at this scale. I will show you one example, but they can all be traced. These are the cases we set up work on. You can see they're scattered a little bit around Europe. These are the number of the storms that we tested. Oh, I'm sorry. Why? Okay. These are the number of events, the reference, and the oceanographic region. The forcing part was all coming out from the Copernicus service. You can see here the different settings. You know that the European scale is an assembly of different models. And specifically regarding the setup of the flood model, we tested these 3 resolutions. We tested a different type of floodplain solver that you can find in the model. We tested different land use friction coefficient. This is an important parameter because very much controls the flooding. And we tested a set of wave setup formulations. Now, the good news is that you can use, as we did, a very basic formulation like this. Basically, you just work on the wave height. The bad news is that you cannot use more specific solutions like this one that is very much of a standard, because the problem is that the most critical part that you need information from, which is in a very shallow water and the upper part of the run-up, there is no data, because the global models, the DTMs, don't have enough resolution. So we came to the conclusion that it was better to use a very coarse approximation of run-up. If better data becomes available, that can be improved, obviously. So I can show you, here is an example of a very famous flood, I'm afraid, from my French colleagues, was mentioned before, Cynthia, in 2010. There is information from satellite imagery. This is the comparison between the model that we set up and observations, but we also used local observation that we have in this database that will be released, point observation. This was an approach that was used in all test cases. If you want to find out more about the different model configuration and the choices we made, of course, you can find the reports if you go to the ECFAS website. Everything is open and available on Zenodo, in fact. But I'll recommend you, for the ones that are more interested in the scientific part, to go and consult this paper, that you can keep track of the scientific choices we made. Now, why a flood catalog? The flood catalog produces water depth and velocity maps, impact layers, and can be used using a forecast of the total water level. So basically, you can also say, okay, I have this prediction of this total water level. I go into my catalog. I find the most similar situation to the one predicted. In the catalog, I also have the expected impact, as I told you, not only the flood map, but the impact maps. And I can use that as a warning. Then you have the issue of producing this, showing this. You have to do some data aggregation, of course. Remember, the scale is Europe. And we decided to aggregate the maps at the level of the NAS3, which is the regional definition of regions used for the land use mapping. We have to segment the whole coastline of Europe in segments which made sense. So we have to do a lot of, using a global shoreline, you have to do a lot of checks that it makes sense. And then to set up the model for each segment using the land use and the dam produced by the Environment Agency. It's an official dam for the coastal zone. This is the typical output. If you go to the ECFAS website, there is a lot of information with us that we're showing the system ran for a couple of years. It's not running anymore because the project is over. But you can see our proposal of the flood system is not necessarily what you would become if this becomes a Copernicus service. But you will have water velocity, which is obviously an important parameter, but it's not calibrated. There are no observations of water velocity normally during a flood like this, when instead there are for the water depth. The flood catalog is for over 500 sectors. For each sector, there are 15 scenarios of combinations also with return period levels of events. This is the information that I will direct you to, that you can download from Zenodo and compare it and use it, not only for operational work, but also for flood estimation, in fact. This is an example for the Cardiff storm case, for the Emma storm in Cardiff. So we were producing these flood maps, and we were comparing with the observations. This is a place where there are observations, in fact. So this is the same approach that was done for every test case. Then we have to move a little bit away from the flood database. You can go and have it, but how we were proposing to use it at operational level. That you see, this is, you can see there is the forecast for CMEMS. Then for every coastal point in CMEMS, we identify where a threshold is exceeded. We did some work doing a reanalysis and choose the thresholds. And then the thresholds for 20, 50, 100-year reference scale period identify the coastal sectors that might have problems. Then for every sector, we propose a system could pull out the flood and impact layers, estimate, and then do an aggregation where you then issue the warning. Green, obviously no warning, red is the extreme. Now, if you look at the work, all the documentation, we believe that this system can run reliably on a 3-day forecast on a daily basis. And this could put up, in fact, bulletins. I'm not going too much into detail into the flood calibration and quality assessment. You can find that in the papers. But you can see the skill score very often was close to 100, which is pretty good for a flood model against observations. Where do you find this stuff? You can find the flood database on Zenodo. On Zenodo, you can find everything. Even the layers we used, that we elaborated, everything is there. You can replicate or enhance this work. This is the paper that you can find also on the workshop website that describes the database itself. In fact, you can find it immediately on today's webpage. And for any further information, here you go, my contacts. Go to the ECFAS website. There is a lot of information, also training information if you want, videos and all the presentations that we did and all the links to the download of the reports. If you write to this mail, it's still active, and even if the project is over, you will be redirected to the coordinator, Dr. Maroli, which can direct you to who did the specific work of each work package. And I think my time is over, and I open for questions. And thank you to WEkEO for inviting me.
Thank you very much, Paolo, for your nice presentation. So we'll move on to the Q&A part. So right now, we don't directly have a question about your presentation. The first one we have for now is about the previous talk, wondering, so does the coastal models or their output that have been mentioned are available online freely similarly to WEkEO? So if I'm not saying anything wrong, well, or Jérôme, you can answer, but most of the models are free, I think.
Well, I don't think they're available, the models themselves on WEkEO, but you can contact us if you want to cooperate and have access to all the information, the references, and so on. So you can contact us. Contact@eoc.eu and my email address, Jérôme@benveniste.space, and I'll let you know what is shareable and what is available as open source. I'm not sure exactly what is shareable now, and ultimately it could be important in WEkEO at some point. Yes.
Okay, thanks a lot for the precision.
If I can, Gael, if I can maybe answer to that as well regarding.
Yeah, no worries. Sure.
You know, in the Copernicus philosophy, everything is open and available. In our case, if you go to the ECFAS webpage and from there to all the Zenodo links, you can you cannot download the list flood model because that is open. You can download it wherever you want, but you can download the grids and all the layers if you want to redo this kind of work at a higher resolution, for example. Obviously, the DEM is the only limitation that you have, but if you have a better DEM for an area, you can redo this work as you wish.
Okay, thanks a lot for the precision to the both of you. So, one question about your work, Paolo. Have you used multi-temporal satellite data sets showing the progress of coastal erosion?
Okay. Remember that this work was very much event-driven, right? So what we were doing on the shorelines, we only focus on the events that then we used for the calibration. Having said that, in the project, a new algorithm for shoreline-derived satellites was developed called SITE. If you search, you can also find the algorithm downloadable directly from Zenodo. And you could use that just the way you do it with Google Earth Engine. We do not use Google Earth Engine. But you will find how to do it. You could use the algorithm to do monitoring of coastal erosion at the site of your choice.
Okay, thanks a lot. Okay, so this question, more of a general question. Where can we find data of the coastal flooding in the Mediterranean Sea? You can find on WEkEO to that.
Yes, on WEkEO you will find the whole data set, and you can extract the part regarding the Mediterranean.
For now, that was it for the question. For the general question concerning the presentation, so no worries, you will have the PDF of the presentation available during the day. You will be able to find all of the links and everything. But yeah, I don't think we will have more questions, so I think you're good, Paolo. So thanks again for your presentation and the question. Well, so thanks again to everyone for all of your presentation. It was really nice having you and having you presenting your work. So thanks again for that. And for the participant, so I hope you enjoyed the day, obviously. And I just want also to remind you that there is a section on the website next to the poll, so next to the Q&A. We would really like to have your feedback on today and what we could provide in the future. And I know lots of you have been happy with the presentation on the chat, so don't hesitate to put this also on the survey. And also, so it's a bit slow. Okay, so also for the practical session, which will be the day after tomorrow. So if you haven't had time yet, I invite you to check the full tutorials to get ready for it. So they are available in full on the event website. So, and there is a tab at the top where you can find the Jupyter, QGIS, and Air sections, all of them using Copernicus WEkEO data. So you can download the data and you can start to practice. There is also a full explanatory video for each of the tutorials. So on day 2, we will have a summary of this tutorial, and you will be able to ask a question to the experts. So yeah, that's it for me for today. Thanks again to everyone for your presentation. I hope you enjoy your coming, and thanks again to all of the participants.